Hello everybody, this is Sanchita and I'm going to brief you all with a few very important, know-hows of the first chapter of 12th CBSE chemistry, haloalkanes and haloarenes. What you need to know and what most students, lack is a few basics of the common names that you should grasp and you should know, so as to the chapter is well understood, and it can be the related questions of this chapter can be solved accordingly. So the first thing that you need to know, I presume that you all know a few things like methane, C2H6 ethane, C3H8, propane, and so on and so forth. The alkanes go up to a huge number of carbons. So your focus should be on the number of carbons that are present in the parent alkane. So suppose I remove a hydrogen from methane, it will become CH3. This will be called a methyl. Do not forget. It becomes an alkyl radical, so it is methyl. Similarly, C2H5 is ethyl. C3H7 is propyl. So on and so forth. So here comes a few questions, like students often do not know what is isopropyl. So I have taught you propyl. What about isopropyl? What is its structure? How does it look like? How are we to know it? So let's go ahead to something called a primary, a secondary, a tertiary carbon. So before proceeding to the know-how of isopropyl, let us go to a primary carbon. What is the meaning of a primary carbon? A primary carbon or a 1-degree carbon is a carbon which has one carbon attached or no carbons attached, provided there is a functional group X attached on the 1-degree carbon. So a 1-degree carbon is a carbon which has one carbon attached or no carbons attached. All right. So basically, if you see, if I put a functional group that is halogen here, halogen denoted by X, which is fluorine or chlorine or bromine or iodine, astatine does not come into this the domain because it is radioactive. So if you notice that this carbon is a 1-degree carbon, and it is an ethyl carbon, CH3, CH2. So this is 1 degree, and the radical I'm speaking of is ethyl. So now from here, let us go to a secondary carbon. This is the secondary carbon where you have a hydrogen attached and a functional group in the form of X, which is once again the same. So this carbon is a 2-degree carbon. The simple meaning of 2-degree carbon is a carbon having 2 carbons attached to it. So now in this case, I started with the question of what is an isopropyl. So I give you the answer. It's a 2-degree carbon where the halogen is attached to the 2-degree carbon. All right, 2-degree carbon. So this is the 2-degree carbon. So this is called an isopropyl. All right, and if I replace the halogen with say chlorine, you will call it isopropyl chloride. So since you know what is a 1-degree carbon, you know a 2-degree carbon, obviously you need to know what is a 3-degree carbon. Oh, you all know the answer, I know it. So this is you must be thinking it's very easy. Yes, it is easy. This is a 3-degree carbon, because the simple logic is a carbon attached to 1 carbon is 1 degree, carbon attached to 2 carbons is 2 degree, and a carbon attached to 3 carbons is obviously 3 degree. Yes, you all have guessed it correct. So this is a 3-degree carbon, and Once again, if you replace the halogen with, say, bromine now, so this will be called a tertiary, tert. In short, tert. Tertiary. The total number of carbons you have is 4. So it is butyl and then bromide. Do not mix it up with IUPAC names. The IUPAC names will come to in my second edition of my video. This is just a training on common names. So this is tertiary butyl bromide where you have a 3-degree carbon. And why butyl? Because there are in total 1, 2, 3, 4 carbons. So do not go to IUPAC names. Just remember the carbons in totality is 4, hence tertiary butyl bromide. So next is 4-degree carbon. So now we come to this particular carbon. You have guessed it right. Yes, this is a 4-degree carbon. And whenever you find there is a 4-degree carbon, the usual rules for common name is that, yes, common names do have rules also, just like IUPAC, and it is fixed. We cannot do any variations as we like. So this is neocarbon, all right? So obviously you cannot put the halogen on this because the tetravalency, you cannot put the halogen on the 4-degree carbon because the tetravalency of carbon is satisfied. So where would you put the halogen? Do not disturb the CH3, this CH3, this CH3. Do not disturb it. Go to the CH2, put a halogen here, and your pentyl is formed. Count the carbons in total. You are right. Count the carbons in total. So this is neopentyl, and put a halogen, say iodine. So this will be neopentyl iodide. Yeah, so our main focus on this video is of common names. So I am done with the monohalogen derivatives of alkanes. There are a lot of things to be discussed. So let us carry on with the monohalogen derivatives of alkanes. I have just taught you isobutyl. What is isobutyl? I have just taught you iso. I have just taught you iso. This is iso, yes. We have done isopropyl. How do we go ahead? The question is, how do we go ahead making an isobutyl? Yeah, that's the question. So this is definitely the 2-degree carbon. Yeah, I have to create a butyl. I have already satisfied the trivalency of the carbon. I have to introduce a 4th carbon. I have no other place excepting to introduce the carbon on the 2-degree carbon and then put a halogen, not on the 2-degree carbon, but on the 1-degree carbon. So yes, that is why you face problems in common names. You do not know where to put the halogen, where to put the hydrogen. Is it 2-degree? So the word iso means 2-degree. I have a 2-degree carbon, but where is the halogen? On the 1-degree carbon. That is why common names have a lot of problems. So remember, whenever you require iso, make this structure and then go on increasing the number of carbons from one side. This is, I have increased the carbon to make it a butyl and then the halide. This is an isobutyl halide. So now you can go on making isopentyl halide also. Try it. I have taught you the trick. Yes, happy? Very good, very good. So you have an isocarbon, that is the 2-degree carbon. You have introduced the halogen on the 1-degree carbon. So that is a problem with the common names. Now they have made a few rules, created from it, and then we try to resolve things for you. Right, so I have explained a few monohalogen derivatives. Now you can try a few variations. Okay, let me, before winding up this monohalogen derivatives, let me ask you to make the structure of neohexyl bromide. So what did I teach you right now? Neo is a 4-degree carbon, 4-degree, make it 4-degree. Yeah, we have made the 4-degree carbon. I asked you not to disturb the CH3s. Do not disturb the CH3. And this CHC which is there, you can go on increasing the number of carbons to meet your requirement. And hexyl means how many carbons? Yes, 6, correct. So 1, 2, 3, 4, 5 and 6. So go on increasing the number of carbons from one side only. That is the requirement for a neo, all right, compound. So this is the neohexyl bromide compound. Okay, so there is a lot of things to be taught. I have finished the monohalogen derivatives. Another thing which I did not dwell on is this the only secondary carbon compound which I have, or can I have some more variations? The answer is yes. This is iso in particular. Then what variation can I have? Look at this. What about this carbon? Doesn't it look like a 2-degree carbon? Yes, it does, no? So is this iso? No, this is not iso. This is secondary, abbreviated as sec. So that is the difference between, iso and sec. See, so this is secondary. How many total carbons are there? What is the method which common name uses? Is carbons in totality. So there are total how many carbons? 4. Yes, rightly guessed. So this is a secondary butyl halide. Now, this is a secondary butyl halide. If I replace the halogen, by, say, iodine, what would you call it? Secondary butyl iodide. Yes? Okay. So let us make another secondary compound. I think now you have understood. Just see what variations I am doing. We be very alert. Be very alert. Make an H. You have to make this secondary. This carbon should be connected to 2 carbons only, not more than that. You either increase the carbons from one side or increase from both the sides to increase the number of carbons. Okay. So this is secondary, 2-degree, you agree? This is secondary. How many total carbons are there? 1, 2, 3, 4, 5. Very good. Pentyl, yes. And the halide. Yeah, so just to recap on things, what we have done today, we have done monohalogen derivatives. Naming, yes, what? Common name. Common name. We did not go to the IUPAC name at all. This is a challenge for students. Learning the common names, remembering the common names, and one chapter's common name is done means you have become mastered at least a little. Okay, so we have done the monohalogen derivatives, names of the compounds, and what names? Common names. Okay, so we have done what? 1-degree naming, 2-degree naming, 3-degree naming, and 4-degree naming in the form of iso, secondary, tertiary, that is third, and neo. Okay, so I hope this video was informative enough for you. You all have learned something. You all have at least done a little bit of practice with me. If you feel that I have done a good work, do not forget to press the like button, share it, and do subscribe. In my next video, we will go to the IUPAC names of these questions. And if you think you already know the IUPAC names, there are still interesting things coming in my forthcoming videos. Do look forward, do subscribe, do share. And thank you so much for watching my video. Bye-bye, everyone.